Okay, for this video, I'll be going through Dynamics Tutorial 1, Mass and Weight. Okay, question 1, what is meant by the mass of an object? Okay, it is actually the amount of metal in the object. The amount of space taken up is actually volume. The material from which the object is made, yeah, it's just the material. So maybe the density is the same for a certain object if it's made of that material. The pull of gravity on the object is actually the weight. Okay, so this is actually the definition for mass. Now, what is meant by the mass weight of an object? Again, it's asking for the definition. It's actually the pull of gravity on the object. The product of the object's density and volume. Now, density's formula is actually mass over volume. So the product of density and volume is actually mass. Okay, the amount of metal which the object contains, so this is actually your mass. The pressure exerted by the object when it rests on a surface, and that is pressure. Just to note, pressure is actually the force over area, and if it's downward force, then it can be your weight over your area. Okay, but for this question, the answer is B. Now, which measuring instrument is used to measure mass? So hydrometer is not really in the syllabus. So to measure mass, the answer is actually using a beam balance. Now, a rock on the moon has a mass of 0.5, so this is the M. On Earth, the rock has same mass, okay, because mass is the amount of metal in a object, in an object, yeah, so it doesn't change. On Earth, it will have more weight. Okay, so it will have more weight because the G of Earth, we take it as 10 Newton per kg. The G of moon, because the moon is smaller, is about 1.6 Newton per kg. Okay, next question. The weight of a standard 1 kg mass is found to be 1.7 Newton when measured using a spring balance on the moon. So actually, if I want to measure weight, I will need to use a spring balance. Okay, and in this case, they take gravitational field strength of the moon to be 1.7 Newton per kg. Now, using the same spring balance, another object is found to weigh 5.1 Newton on the moon. So you can use your formula, W equals to mg. The weight is 5.1, the mass is unknown, and your G is 1.7. So in the end, your mass will turn out to be 3 kg. Okay, so answer is B. Now, astronaut has a mass of 80 kg on Earth. So this is his mass. State whether he's able to jump higher, the same or lower on the moon as compared to jumping on Earth. So he can jump higher. So if I take G Earth to be 10 Newton per kg and G moon is 1.6 Newton per kg, I can then calculate out his weight on Earth and on moon. Okay, so actually a lot of you were able to get till this step by comparing the weight on Earth and on moon. So the second part of this explanation is that assuming that the astronaut exerts a force F downwards on the ground in order to jump. Okay, so by Newton's third law, which we are actually covering now, the floor will exert an equal and opposite force F prime. Okay, so then there will be F net. Right, so in order to jump up, you need to exert a force by yourself to push against gravity. So in the astronaut's case on Earth, if he has a weight of 800 Newton, he has to exert a downward force on the ground so that the ground can push him up. Now, since the weight of the astronaut on the moon is much smaller, with the same applied force, this one comes from his own muscle, his training, his thighs and all that. Okay, the net force on the astronaut is greater. And then by using Newton's second law, because there's now F net, right, we can actually calculate out the acceleration because the mass will remain the same, but the acceleration will be different. So that's why it will have a different height. Okay, he's able to jump higher on the moon.